Every point speaks. Even 0, 0. Listen with me.
Welcome to Reed Bank Ratio Crossing. Take a look at Kit, resting quietly by the water's edge. In mathematics, a point on a graph is a specific location that tells a complete story about two connected, real-world quantities. Watch the scene closely. See how that river otter sorts the reed bundles along the bank. The math is built right into the environment, allowing us to see the quantities physically before we assign them numbers. The environment shows the relationship, and the notation simply records it. By observing these physical actions, we gain the exact context we need to accurately interpret what a graph is telling us. Let's track our first relationship, pounds of apples and total dollars. Notice how the otter deliberately moves those shell markers along the riverbank to keep count. This chart maps that exact process. We start with the x-axis, which measures the pounds of apples. Look at those 4 bundled reeds lining up perfectly with the first number in our coordinate point, 4. Next, we trace over to the y-axis, measuring total dollars. Here, we see 10 small shells grouped together, matching the second number in our point, 10. To read this correctly, always maintain the sequence. You read the 4 first on the horizontal x-axis and the 10 second on the vertical y-axis. When we put those two values together, the point translates directly into a sentence. 4 pounds of apples cost $10. You can avoid mixing up the axes by consistently translating the coordinate notation into a complete real-world sentence, reading strictly from x to y. Now we measure rate over time. Watch the otter swim swiftly down the current channel, passing markers along the way. This graph charts time against distance. The first coordinate is 1.5. On the x-axis, the waterline ticks show us this represents 1.5 hours of travel time. The second coordinate is 90. That maps to the y-axis, giving us the total distance of 90 miles.
0, 0 means none. At 1 the rate. Points tell the price.
The constant speed dictating this point's placement is captured by the equation y equals 60x, carved right into the riverbed. Take a look at the units for both axes. How would you read this point as a single descriptive sentence? The point means 90 miles were traveled in 1.5 hours. Even with decimals and new units, the fundamental framework for translating a point into a sentence never changes. In this final scenario, we use the coordinates for flour and dollars to derive the cost of a single cup. This diagram starts with the coordinate 6, 15. Based on our axes, that means 6 cups of flour cost $15. To find the cost for a single cup, we take the total dollars, 15, and divide them evenly across the 6 cups. Dividing 15 by 6 gives us 2.5. The cost is $2.50 per cup. By unpacking that single coordinate point, we found the constant cost per unit, which gives us the final equation y equals 2.5x. We finish where we started, back at the quiet edge of the crossing with Sedge and Kit. The mathematical notation records the physical movements and counts we observed throughout the crossing. So as you look at this scene, which physical mark proves the mathematical relationship? And how does the animal's action make it true?
Each point told truth. At 1 the rate. Read graphs out loud.